Software Leadership with Uncle Bob Martin.
The Azure and Devops podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. My guest today is a returning guest multiple times. It's Robert C. Martin, and I have the privilege of having him back on the show, someone whose contributions to the field of software development have really shaped not just how we write code, but how we think about it. Robert Martin, more often known as Uncle Bob, has been programming since somewhere in the 1970s and has served as a mentor to really generations of software engineers. And he's one of the original authors of the Agile Manifesto, and he played a foundational role in forming the Agile Alliance as well. And if you go beyond just titles and organizations, Uncle Bob's lasting impact comes through his writing, his lectures, his speaking, and his philosophy of software craftsmanship. He's spoken at numerous conferences around the world: QCon, Agile 2000 and everything, IT Days, countless other industry gatherings, and you can find him always advocating for clarity and discipline and ethical responsibility in code. And if you've ever read Clean Code or The Clean Coder or Clean Architecture or any number of the books that he's written, then you know that he doesn't just teach how to build software systems, but he challenges us to become better professionals in the process. And he has some more recent books, Functional Design and We Programmers as well. He continues his authorship legacy and really distilling decades of experience into patterns and practices and principles that are really just as relevant today as they've always been. So welcome back to the show, Uncle Bob. It's a pleasure to have you. How are you, sir?
Thank you. I am well. Life is good.
Very nice. Very nice. You know, every time you've been on the show a number of times, and certainly people in my generation have kind of cut our teeth in the programming world, reading your books and the things that you had a hand in, and certainly for me. But every day there's more and more programmers that come into the field and start on their career. And so I'm reminded all the time that there are new programmers who are kind of getting to know you for the first time. And so with that kind of younger generation, is there anything that you would say to the young programmers who are just getting into it and haven't read all your books and really haven't studied the whole journey of what's happened in the industry? What guidance would you give that young generation?
Oh boy, oh boy, oh boy. So there is a tendency, especially in the younger side of the equation, to think that AI is going to either replace all programmers or make it so that they don't have to be anywhere near as skilled as they used to be. Like anybody can just prompt a program out of an AI.
Yeah.
This is wrong. I have found AIs to be interesting tools to use. They can sometimes be very helpful. They also do some really stupid things, and you have to be up on your fundamentals and up on your understanding of things to identify those really stupid things and then delete the code that they wrote so that you can improve upon it, because sometimes it's really bad. Like any kind of power tool, very, very useful, but a novice will cut their fingers off. So it takes a fair bit of experience to get to use those tools well. So my first bit of advice to young programmers is learn the skills and then tread carefully with the power tools. Get to the basics first, then you can move on.
Yeah, the stories are already coming out about how somebody who really hasn't worked as a programmer would vibe coded an application and then put it online like, man, shoot, I'm taking credit cards and it's doing this, and then started making some money, and then some didn't have to be much of a hacker, came and poked around and boom, it crashed and burned. So
yeah, vibe coding, great name. Glad somebody came up with that one. I just code by vibe, man. I don't actually write the code. I just kind of think about it, and then the AI will write it.
Yeah. Well, it's the dream. It's like these, Anthropic and the executives who are selling AI, they cast the vision about AI will be able to do, you name it, whatever, automatically. It's going to be great. Give me investor money.
Yeah.
And,
plenty of that going on right now. And I don't want to take anything away from the tools. They're spectacular. The things that these AI tools can do is very impressive. But they do not survive well without human supervision. You better know what you're doing, because otherwise, at least in my experience, these things will go run off in some goofball direction, and you don't know what the heck they're going to produce. So I just recently got a Cybertruck, and the full self-driving is pretty good. It's pretty good. Does some stupid things from time to time. Sometimes it takes the wrong exit. Sometimes it will run a stop sign, and I have to stop it. So not perfect. And that's a bounded problem. I believe the whole full self-driving thing will occur. For a while, I didn't. For a while, I thought that was outside of the realm of simple computation. And that probably is true, but now I think, no, these guys are going to get it. There will be self-driving cars really that are general. I don't mean, the ones that are restricted to a geo-fenced area. I mean, just general, right? I think that will happen, but it's still a bounded problem. Software is not a bounded problem. We have to do all kinds of new and interesting things, and I don't think the AIs are going to be taking that over from us anytime soon.
Well, let's switch from and let's call out one of your most recent book is We Programmers, a chronicle of coders from Ada to AI.
Yeah.
And there it is. So I would recommend everyone, if you're not a reader of Uncle Bob's books, I'd encourage you to do so. He makes you think. So that's the latest book. We'll include a link to it in the show notes. And you've thought a lot about this, and of course, you've seen multiple generations of sea changes. Whereas for me, I started in the '90s, so I saw the big change to the internet, and I saw the big change to the computer is now in your pocket. I mean, there's some other ones, but those are like the huge, right?
Yeah, sure.
Whereas you've seen several more, and so it helps with context. So besides the young programmers, let's switch to programmers who's been doing it for 15 plus years and have haggled about surface-oriented architecture, microservices and layers and design patterns and OR mappers and cloud this. How do you see the nature of it changing with this AI wave for experienced developers?
So there's, in that cohort, there has been I don't want to use the word trend, but there has been a school of thought that all of the things that happened in the 90s are now irrelevant. Design patterns, for example, that's now irrelevant. There's this thread through the internet. You'll find people who have 15, 20 years experience, that's a significant amount of experience. And these folks are saying things like, yeah, no, that old design pattern stuff, that's just out of date and it's too old. And OO is bad. It's bad. We don't really want to do OO anymore. We need to be doing something else. That's one of the threads that's going through the industry. It's very bizarre. There's this idea that old stuff is old and therefore bad. And that's wrong. all of those things, all of those ideas, the design patterns ideas, the agile ideas, the OO ideas, they're all still meaningful, all still good. And I would advise that particular cohort to reassess, at least that thread within that cohort, to reassess their view on that. Because I think they're missing out on an awful lot of very good information and very good ideas. I don't know how that cohort is addressing the AI issue, because I would think inside the mid-level, the journeyman level programmer, I would hope that they're all rather skeptical. Mm-hmm. Right. They're trying it like everybody else. They're hooking up Copilot, or they're using Claude or something like that. Or I happen to use Grok. Doesn't really matter. You use one of these tools and they use it and they think, okay, it's kind of okay, works. It gives me a little bit of this and a little bit of that. If I write some repetitive code, it can actually repeat the code really nicely sometimes.
Yeah.
But I don't think they're as starstruck as the youngsters are. I think the youngsters are really starstruck. And okay, fine. There's another thread inside that cohort that is interesting to me. And this is the thread that goes through hyper productivity, not programmer productivity, hyper performance. We need to squeeze every nanosecond out of the execution, and things that suck nanoseconds out of our execution are things like clean code and OO and design patterns, and all these things are sucking the nanoseconds out of our systems. Now, this originates, I think, inside the gaming community. I think those guys really do worry about nanoseconds. They've got so much crap to put on the screen that they've got to think, okay, nanoseconds really matter. And there's been a number of major YouTube videos about this, and people saying, no, we've got to stop with all that stuff. We've got to just focus on really tight code. And I think that's a problem. Because for most of us, we are far more concerned about programmer productivity than computer performance. For most of our applications, or at least the applications that I tend to encounter in my travel, nanoseconds don't matter an awful lot. Microseconds don't matter an awful lot. And usually we're down in the millisecond level of response times. Right. And that's fast enough. If you're on a web system, or if you're on a desktop system or something like that, if that machine is answering you faster than you can type or faster than you can move the mouse, that's probably good enough. And that's the millisecond level. So if we can save programmer time, if we can make programmers more productive, I think it's worth it. Unless, of course, you're in one of these really high-performance industries, like a gaming industry or missile control. Probably do want the missile to respond at the microsecond level at least. So that's another one of these strange threads that's going through the industry that is not properly contextualized. That's probably the right word to use.
It's not just one answer. There's going to be a lot of answers based on what you're actually trying to accomplish. So I was talking to a CEO yesterday of a company that has heavy software dependent products, and he was kind of asking me my opinion, as I'm sure people you encounter. Oh, you've been in tech for a long time. What do you think about am I going to have to keep employing programmers? And I just. I'm thinking, okay, he's not a program. And I ended up drawing, pulled out my notebook, drawing the software development lifecycle, just the different phases of think about what you want to do, maybe do some design decisions. At some point, you write some code, and then you check the code. Is it good enough? You get ready to deploy that version of the code. And then the basic software development lifecycle, even if it is Kanban style, one feature. And I said, okay, right now, all the AI attention is on making the writing of the code go faster. Okay, great. What if we shrink that time down to zero, or what its natural limit is? You still have to do this other work.
All that
And
other
right
stuff.
now, the industry's not talking about automating away that work. So just, and that helped him out.
Well, okay, good. I'm glad that helped him out. It is a significant issue, right? I like to couch it in terms of detail management. We programmers are the people who deal with the worst of all the details. Managers and customers, they've got a grand vision and they will write a requirements document down, usually very badly, and they'll go walk away and they say, okay, programmers, now do that.
Yeah.
And then the programmers have got to sit there and go, okay, all right, now what happens if they give me a text file, and that text file, the lines in the text file end in \n, but sometimes they end in \r,
Right.
or sometimes they end in \n/r. How am I going to deal with that? Those are the levels of details, that programmers have to think about. I don't think AI is going to solve that. It might give us a little bit of benefit. Maybe some of that lowest level detail will go away. Most of the progress in software has been at the elimination of lower level detail.
Yeah.
But not high level stuff. The high level stuff we all still have to think about, and there's plenty of detail in there that we all have to think about. Like what color should the box turn when the mouse hovers over it?
Right.
Just dumb stuff like that, constantly inundated by these low-level details. And that's our job. That's what we do. We are low-level detail managers, and that will never end. There will always be low-level details for us to manage, regardless of what language we are working in. Will it one day be a prompting language? Yeah, maybe. Okay, fine. But we'll still have to deal with all that low-level detail gunk. All the stuff that the managers and the customers don't want to think about, we're the ones who think about it.
Right. I do wonder sometimes, okay, if the language models do make it to where they could write all of the C# or Java, whatever, in a way that I want it to be written.
Yeah.
Then philosophically, the source code ends up just being different. It ends up being the series of prompts.
Yeah.
Just conceptually, I would think. And so then it's like, okay, well now in that world, it seems like I would be storing the new source code in source control because now, and I have to have some specific language for it to be somewhat deterministic. And so now I'm just like a lawyer with very specific sentences of paragraphs that have keywords that mean very specific things.
It's exactly what that would turn into. It's what it is now, right? We are lawyers in that sense. We are language lawyers. We understand how to say things in entirely unambiguous ways. And okay, it may be one day that it's all prompting language, but you're right. It'll all have to be put into some kind of control mechanism. It'll have to be filed. Maybe that's source code control. Maybe it's prompt control. Who cares? But it's all going to be the same. And we will be the ones who have to write the deterministic language that the AIs use. And if you think about that carefully, you'll realize that is the obvious evolution of computer language. Grace Hopper started, I plug the book again, right? So I talk about Grace Hopper in here. She started writing code by literally punching holes in paper tape, one hole at a time. Punch the hole. And then she would have to check those paper tapes, and then the paper tapes would get read through the machine. She was working entirely in binary. And it wasn't even binary. It was just a 1-bit code that was encoded in holes in paper tape. Not even quite binary. And from that point, it went to assembly language, and then it went to Fortran, and then we got even better languages. And at every stage, there was this increase in abstraction and decrease in detail. And the automation dealt with the detail. So, the automation eventually punched the paper tape. And then eventually it wrote the assembly language, right? And now we've got compilers that compile down to JavaScript, which is bizarre to me, but we seem to have a lot of those now. And the prompt language is just another language that will compile down to something. Don't know what. Might be Java, might be Clojure, might be God knows what. I have it write Clojure for me. It seems to do a pretty good job.
Mm-hmm. Yeah. And I end up saying this a lot to non-technical people. Nobody wants to write code. Nobody wants code. What we want is a computer to do something for us so that we don't have to do it. And code just happens to be part of the process of getting the computer to do something for us. So, then all of this would stand to reason that even if the futurists are right about tons and tons of code being written automatically, software engineers still have to do the work to figure out how to get the computer to do what's needed.
That's certainly true. And one of the things that we have seen over the last 50 years is that with every increase in abstraction, there was an initial fear that increase in abstraction would reduce the number of programmers. A whole bunch of programmers would be put out of work.
Yeah,
and the exact opposite happened.
Yeah.
Every new level of abstraction opened up new options. And those new options meant that there was a greater demand for programmers. And I don't see why this revolution will be any different.
Yeah, right. Because if certain things that used to be hard do become easier, whether incrementally or whether massively easier, well, then that just means that we can do more interesting things.
And there are so many interesting things to do.
Yeah, right. And who would have thought, back to your Cybertruck analogy, who would have thought that there would be a whole lot of software controlling every control surface of an automobile?
Who would have thought that there would be a Wi-Fi connection to my refrigerator?
There you go. Yes.
Yeah. I get alerts.
And stove and oven.
In my watch. Someone has left the refrigerator door open.
Oh, great. Yet another alert. Love it.
I'm inundated by alerts. My watch is yelling at me all the time. One thing or another. So, yeah, I mean, there are so many more interesting things to do. There are so many more applications. I doubt that we are going to see a decline in the demand for programmers anytime soon.
Yeah, I agree with you. And one of my upcoming training courses has a whole module on AI-driven development, just to kind of, okay, we're writing code now. AI is new. Let's use it. It's not, is it going to put us out of a job? Let me wring my hands. Let me be worried. But it's like, okay, I do remember people who criticized the early smartphones and the computer in your pocket and the Windows HTC little candy bar phone. And then the BlackBerry was, okay, it's interesting for certain things. And they poo-pooed the idea of writing software for a pocket computer. And now it's like, okay. Or the same thing with, desktop resisting the internet. So here's the next wave. It's like, we got to use it. How do we use it?
When Grace Hopper came up with the first idea for a compiler, she coined the word compiler. This is in the early 1950s, right? And she's thinking, I got to stop punching holes in paper tape. There's got to be a better way. And the programmers at the time thought, oh my God, that's terrible. We're all going to be out of a job.
Did they really? Wow.
There were a whole bunch of arguments about why that's a terrible idea. She called the process automatic programming, right? The computer would now be doing the programming. That's how she phrased it. Okay. And so all the programmers are like, oh no, the machine is going to take away our job, which of course is not what happened.
Yeah. It took away the poking action. Took away.
The hole punching went away.
Right. So that would stand to reason. Maybe, and I remember a college course on certain generation languages and fourth generation language. I mean, who knows if there is a domain specific language that's essentially prompt segments and you kind of layer them on top of each other. Yeah. Hey, maybe that does maybe that does do a good job of like a pre-compiler. The prompts pre-compile into, for me, C#, and then okay, C# does the JIT compiler, but who knows? Maybe we end up with something like that.
I probably will. It's okay. Just
Yeah.
another language.
Yeah. Exactly. Yet another language. But we still have to be very specific and know how to get the computer to actually do what we want it to do, because people in the business are, well, I assert, people in the business are never just going to become programmers.
No, there's going to be a group of people who are going to want to wave their hands around and say, okay, now just do what I waved. Then there's another group of people who have to turn that into a reality.
Well, let me ask you about the Agile side of it, because one thing that I saw in my career was, my first project was PMBOK and Waterfall at a big company before Agile kind of set in my world. And so I remember the shift on the big requirements documents and design phases, and then we go to the one piece at a time, a smaller set, more constant flow. And I've seen people who should be thinking about what they want and would have put together a requirements document, now put together a requirements sentence. And they've been told, oh, the user story this, and it's just a placeholder for a conversation and various things which end up basically not fully fleshing out the articulation of what is desired. And then there's, a couple sentences for make it do this, and you're at the programmer sitting there like, okay, so what am I trying to do now? So the Agile seems in some circles has played out. Now there's a lot of people thinking, well, what now? Should I still be looking at Agile? Should I be looking at something else? What's your view?
So another one of these threads through the industry over the last several years has been the horrors of Scrum. Oh, Scrum just destroys teams. And there's been a whole bunch of very bad experience reports and people saying, I worked on an Agile team once and it was absolute hell.
Yeah.
And then you dig into it and find out that, it was actually not an Agile team at all, but they were trying to be hyper religious about certain rules, or they were actually doing waterfall with an Agile cloak over the top. They called it Agile. It was really something else. My reaction to that is, the Agile movement was meant to solve a problem of small teams. How do we get small teams to do relatively small things in an efficient way? Mm-hmm. And I think the Agile method, the Agile movement managed to do that quite well. You take a small thing and you break it down into a bunch of smaller things and you iterate over them very carefully and you measure your progress. And I think that works. So the method that I like to use is the old extreme programming method. Kent Beck's book, Extreme Programming Explained.
Yeah.
I would follow that pretty closely. And I think that works out very well. What's happened to the Agile industry? It's two things. One, it was completely taken over by the project managers. They really liked the idea of the certified Scrum Master thing. Certified Scrum Master. I can have that on my resume. And they poured into the industry, just poured in, completely took it over, took over the conferences, took over the whole message. And it became the Agile project managers, world. This is ironic because, Agile was invented by programmers. The 17 guys at Snowbird who wrote the Agile Manifesto, we were all coders. A couple of managers in there, but they used to be coders, right? We were all coders at the time, and we were just trying to answer this simple question. How do you get 7 or 8 guys to work on something that's on the order of 100,000 lines of code in a reasonable fashion? Mm-hmm. So the project managers swept in and they kind of wrecked it on that side. And then another thing happened, which is everybody started thinking about, well, okay, how do we do software in the large? How do we take Agile and make it really big? Mm-hmm. And Agile was never meant to be big, right? So now, of course, you've got these great big models. I can't remember the names of them. They've put all kinds of adjectives on the front of the word agile. There's
like scaled agile
and fancy agile and red. I don't know. It was just lots of adjectives. But they're all towards this idea of getting multiple teams to work in a single agile way. And that was not the problem we were trying to solve. It seems to me, and this is what I wrote, by the way, in yet another book, so I'll get that book out too.
Nice.
Oh my, let's see, where's that book? Clean Agile. Where is it? Oh, well, it's up here somewhere in my shelf. I've got a book named Clean Agile. And what I wrote in that book was, look, the problem of making many teams work together is a solved problem. Just in general, it's a solved problem. We've been doing that for 5,000 years. Yeah, we built the pyramids. We won World War II. I can say safely that we won World War II. We won World War II. That was the problem of getting many multiple teams working together. Right? We know how to do that. The thing we didn't know how to do was to get one team to be productive. One software team to be productive. And that's what Agile solved. So the issue of making it bigger is in my opinion, a misdirection. Because we know how to do that. We know how to assemble multiple teams together. That just takes normal, good old project management, operations, research stuff that's been known for years.
Mm-hmm.
What we didn't know how to do was get 5 or 6 guys to work efficiently together. And that's what Agile solved. And I think it still does.
Yeah, it's funny to me how I agree that that is a solved problem, but it's still not universally adopted. It's like it's out there. Yeah. The state of the art is known. It's a solved problem.
Brushing
your
teeth is not universally adopted.
Yeah, right.
Okay, you can send the message out, and some people will say, that's a really good idea, and some people will say, I'm never going to do that. Okay.
Right. Well, the industry's also been growing so fast. The universities can't keep up. The different education boot camps. It's like anybody who raised their hand and said, "I want to be a programmer," is like, "Here's a job as a programmer."
The universities have never kept up. The universities have always been 10 years behind. There's a few notable exceptions to that, but usually the universities are playing catch up, and the industry is way ahead of them. So the kids come out of university, they think they know something. And then they get put into a job and they're like, wow, that's nothing like it was when I was in college. It's usually quite a bit of sticker shock going on there. And one of the reasons behind that is I don't think most of the professors have ever coded in anger. I don't think they've ever worked in a coding environment. There are a few who have, but I think most of them have remained academic. It's been an academic thing for a long time. And software is not at the academic phase. We're still trying to figure it out, and we figure it out in the trenches. So all the innovations are coming out of the trenches, and then they wind up at the university level, and they age out. So I think learning to be a programmer at university is something of a disadvantage. Learning to be a programmer by getting a job early and working with people is probably the best way to do that. And I mean, you could probably go to, if you're a young person and you want to become a programmer, the best route is probably a community college for a couple of years and then get a job. Get a job as fast as you can and work as a grunt programmer for a couple of years, being supervised by guys who know what they're doing. And you'll come out the back end of that with a much better education than if you go to 4 years at the university and you come out with a CS degree and then you wind up in a job where it's like, what the hell happened to the usefulness of my degree? Anyway, that's the way I feel about the university system. I don't think it's serving the software world particularly well right now. The boot camps, those guys, it's not a bad idea. The boot camp's not a bad idea, but I think they make promises that they can't really keep. You can't take somebody and through 13 weeks turn them into a programmer that is much better than an extremely junior person who needs an awful lot of supervision.
Right. But perhaps the trade school model might be more effective than the university model for getting those young programmers going. Because
I definitely think so.
And so the boot camps that definitely fall under trade school, but they're so small and bounded of 9 weeks or something.
Yeah.
Whereas if I think about electrician or car mechanic or plumber, or welder, it's well established vocational path where, okay, you're going to come out and you are going to have done a set of things during this vocational school. And then they turn to all the employers and say, okay, these employers want people who've done these sets of things.
Yeah, my son runs a company, cleancoders.com. He runs this company, and the way he brings programmers in is through an apprenticeship model. And it takes months, right? These guys come in, they've already gone through some kind of a boot camp or something else. They already know enough about coding that they think they're programmers. And then he will hire them at a fairly reduced salary, and he will run them through a gauntlet. They've got to write a bunch of fairly complex software. They got to write a web server from scratch. They've got to do a bunch of other things from scratch. But then he turns it around. And he says, okay, now you have to give a talk. Now you have to write a paper. And the focus of the apprenticeship process is to create a well-rounded programmer who, yes, can write code and write code pretty well, but can also articulate and communicate and become a functioning part of an enterprise, I don't want to use the word enterprise, of an organization, right? Where you can fit in particularly well. And this has worked pretty well for him. He's gotten a lot of guys that are very well trained, very, very adept at getting software done.
Awesome. Yeah, it's effectively on-the-job training.
Yes, it is
on creating,
But you're not allowed to touch client work for probably 3 months or more. Not until you get out of the apprenticeship program. So the apprentices cannot touch client work. It's interesting. It's very interesting stuff, and it works.
We'll include a link to that in the show notes as well. Maybe some people will be some of the listeners are interested in that program. Fantastic. Well, as we close up here, is there anything else that the listeners should hear as we close up?
Oh my goodness. I am in the midst of writing the second edition of Clean Code. My publisher came to me a while ago and said, you ought to write a second edition. And I thought, I've never written a second edition of anything. It's like, I've got too much to write. I've got too much other things to do. I don't want to go back and write a second edition. And then I thought about it for a while, and I thought, well, you know what? If I were to write a second edition, it would probably just be a completely new book. And that's what I've been writing. It's just a completely new book. There's some older chapters that are highly edited, but mostly it's just new stuff. Just poured into it. So it'll be the second edition of Clean Code, or the second, I don't know, coming of Clean Code. I don't know how you best to say it, but it's an entirely new book that I think is going to be available by the end of the year. I'm pretty close. I'm done writing it.
Yeah. Okay.
It's in production at the moment. I think it's going to be out pretty soon.
Fantastic. Well, the original one has certainly made a good impact. So the second one will too as well.
Oh, I hope so.
Yeah. Well, awesome. Do you have any conferences or speaking coming up on the calendar that listeners should watch out for?
Since COVID, I have traveled very little. If I do a conference, it'll be from Zoom, probably. Generally speaking, I don't do very many anymore. Focus on writing. I focus on my other activities. I'm, 72 years old, and I'm very happy as a quasi-retired, but not entirely retired, individual. If somebody wants me to speak at a conference, it's something I would consider. But I'm not really anxious to get on the road again. I spent a lot of time on the road prior to COVID. I was hopping all over the doggone place. Funny story. I was in Ireland in March of 2020.
Okay. Ooh. Bad time. Yeah.
Yeah. So, and deep in Ireland by Shannon, and doing a 1-week course. It was an extreme programming course. I was teaching those quite a bit back then. And my customer calls me up at 3 a.m. on a Wednesday, I think it was, and says, you've got to get out of town. You've got to get out of town. Now there's a taxi downstairs at the door of your hotel. Throw clothes into your suitcase, get in that taxi and get the hell out of here. And I did that. He had it all arranged. I wound up at the airport, in the air, boom, landed Chicago, about an hour or two before they closed down the immigration.
Wow.
Yeah. Just so I snuck back into the country by the skin of my teeth. And since that point, really haven't traveled very much. And it's okay. I don't need to travel anymore.
Well, certainly very, very few of our clients have requested travel. So, yeah, 2020 and 21 changed a lot of things.
Certainly did.
But, well, thank you so much for coming back on the show. A fascinating conversation for me, and I'm sure for the listeners as well.
My pleasure.
And we'll include links to those books and everything we talked about in the show notes. But Uncle Bob Martin, thank you for sharing your thoughts on where AI is going and how people should think about Agile. Appreciate it.
Sure.
And until next time, dear listener, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.